Hello guys, welcome to my YouTube channel. Myself Dharani.B.N. I am presently graduating in Sri Venkateshwara College of Engineering. I am from CSC department. Today I am going to discuss briefly the parameters of animation which involves the concept of physics. First, we can see that what is meant by animation. To animate literally means to give life to. Animating is moving something that cannot move on its own. Animation adds to graphics the dimensions of time which randomly increase the potential of transmitting the desired information. In order to animate something, the animator has to be able to specify directly or indirectly how the thing is to move through time and space. Let us see that there are many principles of animation. First, anticipation, arcs, slowing and slow out, appel, timing, 3D effect, exaggeration, stagging, secondary action, follow through, overlap, squash and stretch. Let us discuss one by one. Introduction to animation and physics. Animation combines artistic creativity with scientific principles. Understanding the laws of physics enhances the realism of animated sequences. This presentation explores key parameters of animation that align with physics concepts. Next, timing in animation. Timing refers to the speed at which action occurs in animation. It is essential for conveying weight, emotion, and realism in movements. In physics, timing relates to the concept of velocity and acceleration. Next, anticipation. Anticipation prepares the audience for an upcoming action. It involves a smaller movement before a larger action akin to potential energy. This principle helps establish expectations and enhance the believability of movements. Next, swash and stretch. Swash and stretch add a sense of weight and flexibility to objects. It mimics the physical properties of materials, illustrating how they compress and expand. This principle emphasizes the laws of motion and energy conservation in physics. We can see the left right side diagram. Squash and stretch. This action gives the illusion of weight and volume. It is one of the most important elements you will be required to animate and will be used to obtain. And next, follow through and overlapping action. Follow through refers to the continuation of movement after the main action is stopped. Overlapping action involves different parts of a character or object moving at different rates. This concept reflects inertia and momentum, demonstrating relative motion. See that right side diagram, we can see that follow through when the main body of the character stops, all other parts continue to catch up to the main mass. And next we can discuss slow in and slow out. Slow in and slow out create a more natural movement by easing into and out of action. This principle is essential for mimicking human and animal motions, which are rarely abstract. In physics, this corresponds to the acceleration, deacceleration of moving bodies. In right side diagram, we can see slow in and slow out. As an action starts, you may have more drawings near to the first phase. We can see that in the diagram. First diagram we can see one or two in the middle and more designers near the next phase. And fewer diagrams make the action faster and more drawings make the action slower. Slow ins and slow outs obtain the action which making its legs abstract. Okay, next we can see that arcs in motion. Arcs refers to the curved paths that objects follow when in motion. Natural movements obtained occur in arcs reflecting the laws of gravitation. This principle adds fluidity and grace to animations, making them more visually appealing. First diagram we can see that arcs of bouncing ball. The ball is bouncing. We can see that in first diagram, and second diagram we can see that arc of a moving arm. These are the two examples for arcs in motion. Next, let us discuss exaggeration. Exaggeration is used to emphasize actions or emotions for comedic or dramatic effect. It can amplify physical properties, making movements more striking and memorable. In animation, this principle operates within the framework of physics to enhance storytelling. Right side diagram we can see that help make actions clear, helps emphasize the story points and emotion, most balanced with non-exaggerated parts, timing for action and Whitaker and Alas. Next, tagging. Tagging involves the arrangement of elements to clearly convey the story or emotion. Effective tagging considers the audience perspective much like a physics experiment. This principle ensures that the intended message is communicated with confusion. And we can see that in right diagram, poor tagging and good tagging. And finally, conclusion. We can discuss in first to many of the things: tagging, slow in and slow out, exaggeration, arcs in motion, and etc. etc. Finally, we can consider conclusion. Understanding the physics behind the animation parameters can greatly improve the quality of work. Integrating these principles allows animators to create a more lifelike and engaging animation. The fusion of arts and science is essential for the evolution of animation techniques. Thank you for watching. Please subscribe.